This video is about direct variation. And direct variation sounds like a really fancy subject, but it's actually quite a simple topic when you look at it the right way. I'm going to come about it kind of through the back door and look at it from a different angle than most people look at it. But I think it makes more sense this way. If I have a unit rate, let's say I have a unit rate of 3 apples per tree. I have no idea what that represents. Maybe there's 3 apples per tree that have a worm in it. Doesn't matter. Then that means I can make a table. So I have my X, I have my Y. And if I have, I'm going to skip the first spot for a reason. If I have 1 tree, then I have 3 apples. And if I have 5 trees, then I have 15 apples. If I have 6 trees, I have 18 apples. If I have 0 trees, then I have 0 apples. This represents unit rate, and we know it's unit rate because the ratios are constant. But this has something also special, is that these are collinear. And unit rates are always collinear because they always make a line. You will notice the slope from here to here is 3 over 1, which equals 3. And the slope from here to here is 12 over 4, which is also 3. And the slope from there to there is 3 over 1, which is 3. Now, it's not a coincidence that all of these slopes are 3 and that our unit rate is 3 apples per tree. So, slope 3, unit rate is 3. Well, we also have something that I really want you to pay attention to. I want you to note that it goes through the origin. So let's write down some things we know about unit rates so far. So unit rates, we know go through the origin. And we know that they have a constant slope. And we know that the slope is equal to the unit rate. Well, how would that look on a graph? So we know those things. Let's see, what would that look like on a graph? Well, if I have a graph, and I'm not going to do anything fancy at all, but let's say I have 1, 2, 3. These are my trees. 1, 2, 3. Well, over here I would have 0 trees. And then over here I would have maybe 3, 6, 9, 12 apples. And for 1 tree, I would have 3 apples. And for 2 trees, I'd have 6 apples. And 3 trees, I'd have 9 apples. And so on and so forth. And if I graph this, if I had 0 trees, I would have 0 apples. If I graph this, I get this nice line. And that line could have a slope triangle. And this slope triangle has a run of 2. And this goes from 9 to 3, so that's a height of 6. And so that slope triangle tells us that we've got a slope of 3. So now we have, this goes through the origin. This has a constant slope. And the slope is this rate that we have. So direct variation is when we have a unit rate, which is the same thing as having slope constant and through 0, 0, which is our origin, which is the same thing as having a line through 0, 0, which is our origin. So unit rate is the same thing as having the slope constant going through 0, 0, which is the same thing as having a line through 0, 0, which is the same thing as having a linear table through the origin, 0, 0. Well, that's a lot of things. So we know the slope is the only thing, and it goes through 0, 0. Well, I wonder what the equation of the line would look like. Well, the equation of the line would look like this. Y equals kx. Now, this k is really the same thing as the slope, but it stands for constant of variation. And you might wonder why they're misspelling the word constant. It's because the letter C is taken up for something else that you'll find out later. It's actually taken up for constant in another case, though. So the constant of variation is the slope. So K is the unit rate, is the slope when we have a line through 0, 0. And it is simply the slope of that line that goes through the origin in a graph. That's really all it is. And so if we can get something to look like y equals kx, then we know it has constant variation. So an easy example is y equals 1/4 x. That is in the form k equals 1/4, y equals kx. So y equals 1/4 x. We know that the slope is 1/4. We know k is 1/4. We know it goes through the origin. We know all these things about it. We know the unit rate is 1/4. And now we can have these look a lot more complicated. If I say 3y equals 2x, is that direct variation? Well, can I solve for y? Well, yes, I can. I can solve for y by dividing both sides by 3. I get y equals, this looks like 2x over 3, but that's really the same thing as 2/3 x, because I can clump all the numbers together. And that is direct variation right there. So we need to be careful. Sometimes people get confused and say, oh, okay, that looks like direct variation. What if I had y equals 3 over 2x? Well, that x is still downstairs. We could rewrite it as y equals 3/2 times 1 over x. But that does not look anything exactly like y equals 3/2 x, because 1 over x and x are not the same thing. And there is no way that I can get it in this form. And so it does not have direct variation. So what if I have y equals 4x plus 5? Can I get that to be y equals kx? Well, we know the slope is 4, but how can I get rid of that 5? Well, the answer is I can't get rid of that 5. And so this does not have constant of variation, so it does not have direct variation. Similarly, if I have y plus 3 equals 2x, I can't get rid of that 3. I can subtract it from both sides, and that gives me y equals 2x minus 3, but it's still stuck here. It is not in the form y equals mx, or excuse me, kx. I'm so used to slope being m. Y equals kx. I cannot get rid of that minus 3, so it does not have direct variation. There's lots of examples. I could have y over 7 equals 2x. Well, this one does work because I can multiply both sides by 7, and that undoes that. I get y equals 14x, and we're done. That is in the form y equals kx, and so the constant of variation is 14 in this case, and so it does have direct variation. So direct variation, again, means it's a unit rate or a line through the origin, 0, 0, or it's in the form y equals kx, or at least can be put into that form, or it's a table that is linear and goes through 0, 0. Any of those being true is the same thing. They are all equivalent statements. So if you say you have a unit rate, that automatically means you have a line through 0, 0. That automatically means you have y equals kx. Automatically means you can make a table that is linear that goes through 0, 0. If you have a table that's linear that goes through 0, 0, means you have y equals kx, means you have a line through 0, 0, means you have a unit rate, and so on and so forth. That is what direct variation is.